This is the video for 5.8 and we are talking about absolute value functions. An absolute value function is a V-shaped graph that opens up or down. This is the equation of an absolute value function, and you can see what the equation tells us about our vertex. This is the x-coordinate of the vertex, and this is the y-coordinate of the vertex. The graph of an absolute value function is going to open up if a is positive, and it's going to open down if a is negative. So remember what a parent function is. It's the simplest form of a function. The parent function of a straight line is y equals x. So that's the simplest form of a straight line. And from that, what can we do? We can change the slope or we can change the y-intercept, but y equals x is the parent function. It's the simplest form. This is the same concept. This is the equation of an absolute value parent function, and this is the graph of an absolute value parent function. So if we write out the equation of an absolute value parent function, what do we see? What does this tell us? It tells us that a is 1 and our vertex is at 0, 0. So from that, what can we do? Well, I already said we can make a negative and we can make this graph open down. We can also change the value of a and we can make this graph wider or more narrow, and we are actually not going to be doing that today though in this lesson. But we can change the vertex. We can shift this graph to the right or left, and in doing so we will change the x-coordinate of the vertex, or we can change the y-coordinate of the vertex by shifting the graph up or down. But this is the parent function. An absolute value function is an example of a piecewise function. A piecewise function is a function that has different rules for different parts of the domain. Remember what the domain is. The domain is the possible x values. So if you look at the graph of an absolute value parent function, we can say for this part of the domain, the function rule is y equals x. But for this part of the domain, the function rule is y equals negative x. So an absolute value function is an example of a piecewise function because it has different rules for different parts of the domain. A step function is another example of a piecewise function. A step function looks something like this, and you can see how it has different rules for different parts of the domain. A step function is a function that compares every number in an interval with a single value. This is an interval. So let's look at this interval, for example. What is this telling us? This is telling us that when x is greater than or equal to 1 and less than 3, y is going to be 1. It compares every number in an interval with a single value, and the single value here is y equals 1. That is a step function. And finally, what is a translation? It's a shift of a graph horizontally, vertically, or both. So that's what we're going to be doing today. We are going to be translating these absolute value functions to the right, to the left, and up and down. So we're going to be translating these absolute value functions horizontally and vertically. So let's start with vertical translations. I can look at this equation and I know that the vertex is going to be shifted down 2 units from the parent function. The vertex of the parent function, remember, is at 0, 0, and this graph is just going to be shifted down 2 units. So how do I know that? Just by looking at it. remember what the equation of an absolute value function tells us. It tells us just by looking at it where the vertex is. Here, the vertex is at 0, -2. Because this is the same thing as saying x plus 0. So the vertex is going to be at 0, -2. So whenever you have a situation where you have minus k, that means it's going to be shifted down k units. So now that I told you that, go ahead and predict what the graph of this equation is going to be, and how is this going to be related to the parent function. So this graph is going to be shifted up 4 units from the parent function. And again, how do I know that? This is the same thing as saying x plus 0. So my vertex is at 0, 4. So whenever we have a situation where it says plus k, that means it's going to be shifted up k units. So the whole point of this is so you can just look at an absolute value equation and you know how this has been shifted. So I can just look at this and I should be able to tell the vertex is at 0, 2 and it has been shifted up 2 units. I should be able to just look at this and be able to tell the vertex is at 0, -7 and this has been shifted down 7 units. So that's the skill that you need to develop. So now we are going to talk about horizontal translations, and this is a little trickier, so pay attention. If I have x plus 5 inside the absolute value bars, I know that this has been shifted to the left 5 units. The vertex has been shifted to the left 5 units from the parent function. Well, how do I know that from looking at it? Well, first of all, remember what the equation of an absolute value function is, and remember what that tells us about the vertex. And be careful, because in this equation, this is -h. So your vertex is h. So your vertex, the x-coordinate of your vertex, is always going to be the opposite of this. So let me give you an example. If we say y equals the absolute value of x plus 5, knowing the equation is x minus h, this is the same thing as saying x minus -5. So pause the video and make sure that you understand how this and this is the same thing. If it's -h, what we're saying is this is x minus -5, if the equation says x plus 5. So I have plus 0 for my k, so then what do I know about my vertex? My vertex is at -5, 0. And it makes sense if you think about it. When is y 0? Y is going to be 0 when x is -5. So I need to shift my vertex to the left 5. So that is why whenever you have a plus h inside the absolute value bars, that means this vertex is going to be shifted to the left h units. Okay, so now go ahead and take what you know about what I just told you and go ahead and predict what will the graph of this be and how is this going to be related to the parent function. This graph is going to be shifted to the right 7 units. My vertex is going to be at 7, 0. Because this is x minus 7, so it's x minus h, so h is 7. So whenever I have a minus h inside the absolute value bars, what does that mean? It's shifting to the right h units. Okay, so now Go to example number 4, pause the video, go to example number 4, and go ahead and predict just by looking at it without graphing, what is the vertex going to be and how is this equation going to be related to the parent function. And here are your answers. This is going to go to the left 2 units, so my vertex is going to be at -2, 0. And this is going to go to the right 8 units, so my vertex is going to be at 8, 0. And if you get confused, just remember this. You have to think, when is y going to be 0? Y is going to be 0 here when x is +8. My vertex is at 8, 0. Here, when is y going to be 0? Y is going to be 0 when x is at -2. So my vertex here is going to be at -2, 0. So remember, these are +0. This right here is +0. This right here, same thing, it's +0. So we're saying the y coordinate of the vertex is going to be at 0.